Substances undergo changes when heated and cooled, such as expansion and contraction. Best example is the rising of liquid thermometer when high temperature is detected. This phenomenon, known as thermal expansion, has an important role in engineering application. Buildings, concrete highways, railroad tracks, brick walls, and bridges undergo dimensional changes as the temperature changes. For linear expansion, a thin metal rod is heated from initial temperature to a new uniform temperature. Its length increases from original length to a new acquired length. The change of its length is denoted as delta L. This change is proportional to the change in temperature, as well as the initial length of the rod. This concept is represented by these formula of linear expansion, where alpha is the coefficient of linear expansion for a particular material. Same concept is for volume expansion. The change in volume, delta V, is proportional to the change in temperature and initial volume, where beta is the coefficient of volume expansion of a particular liquid. Heat spontaneously flows from hotter object to colder ones, long enough for their temperatures to be equal. Heat flows from a stove burner to a pot of soup. From the sun to the earth. From a hot coffee to a mug. But if this flow of heat make the object increase in temperature, how much does the temperature rise? Experiments in the 18th century recognized that the heat, denoted as Q, required to change the temperature of a given material, is proportional to the mass of a given material, represented as m, and to the change in temperature, delta T. This is presented by this simple formula: heat, denoted as Q, is equal to mass m times C in delta T. C is the specific heat of a material. This value was determined experimentally by previous studies and was given in tables. Take note that the SI unit for heat is in joules, mass in kilograms, and temperature in degrees Celsius. This simple relationship with heat and the rest of the variables will help to calculate the amount of heat transferred to a given material. Calorimetry is the process of measuring the amount of heat released or absorbed during a physical change of a particular system. In physics, a system is any object that we want to consider. And everything that surrounds a system, or the rest in the universe, is referred to as environment or surrounding. There are several categories of a system: closed system, open system, and isolated system. From the law of conservation of energy, heat loss of a system is equal to heat gain that enters a system. To apply this theory, consider this sample problem. A 0.05 kilogram bar of metal is heated to 200 degrees Celsius, and then dropped into a beaker containing 0.4 kilogram of water initially at 20 degrees Celsius. If the final equilibrium temperature of the mixed system is 22.4 degrees Celsius, find the specific heat of the metal. With the specific heat of water given in tables, and using the law of conservation of energy, where heat is equal to mass times C, specific heat, and delta T. By simple manipulation and substitution of the given specific heat of the metal is 453 joules per kilogram Celsius. Heat transfer from one object to another occurs in three different ways or mechanisms. Conduction, for example, you place a spoon in a bowl of hot soup. The end of the spoon becomes hot as well, as you hold it, even though it is not directly in contact with the source of heat, which is the soup. In this case, heat is conducted from the heat source to the cold part of the object. As for convection, liquids and gases can transfer heat through convection. This involves movement of molecules from one place to another, over large distances, from hotter to cooler area. The wind that travels in global scale, and the weather, is a result of convection of air currents. Another example, a heater inside the balloon heats the air, and so the air moves upward. The trapped air inside the balloon moves upward, causing the balloon to rise. Conduction and convection requires any medium or presence of matter to carry heat from hotter to colder region. But the third type of heat transfer occurs without any medium at all. Life on Earth depends from the sun's energy. This energy transfer is called radiation, and takes place over empty space.